All right. All right, guys. Today we're going to be looking at calculating pH. So your learning targets and success criteria are that you guys can calculate the pH of a solution. So if you're given the molarity and hydrogen ion concentration, you guys can calculate the pH. Okay, you guys can calculate the pOH of a solution using the molarity of hydroxide ions, and you guys can calculate the pH if given the pOH. You guys have done all of this. Well, I guess for those of you guys who are here on Friday, you've done all of this. Okay, you guys just learned a little trick to do it without a calculator. Okay, that trick being that if we have a hydrogen ion concentration, remember a hydrogen ion is what makes an acid an acid. If we have a concentration of hydrogen ions in molarity, and it's equal to 1.0 times 10 to the negative 8. What is our pH? Buck? 8. Okay, it's just that exponent. What would make that untrue, or what makes that a true statement, Ty? Right. If you're looking at H and OH, if those two don't line up, what else would make that an untrue statement? It's not 1.0. Were you here on Friday? Oh. I was like, dang! If it's not 1.0, so if we have 1.0 times 10 to the negative 8, then our pH is 8. 8.00000. If we change that 1.0 to like 2.76 or 1.01, it's no longer exactly 8. It will be close to 8, but it won't be exactly 8. Okay? Today what we're going to do is we're going to learn the actual formula and how to use our calculators to calculate what our pH is if we're given a number that isn't 1.0 times 10 to said negative exponent. Okay, so 59, calculating pH. Okay, just like we did on Friday, you guys are going to use the hydrogen ion concentration to calculate our pH. Okay, anytime you guys see those brackets, what does that mean? That we're using concentration. What do we measure our concentration in? Good, concentration and molarity. It's really hot in here. Okay, so we'll be using that to calculate pH. Okay, the formula we use for that is the pH is equal to the negative log of the H plus concentration. Okay, big thing to remember with all of these formulas that we're going to talk about today is there's usually a negative in them somewhere. Do not neglect the negative. You will get the wrong answer. So negative log of the H plus concentration. So you guys will be given some molarity of hydrogen ions or some molarity of an acid. And you guys will plug it into this formula, hit enter, and that'll solve for your pH. What are you looking at, Tristan? Because it's math. I don't know. And that's where pH comes from. You guys see the H plus? That's where the big H comes from. Okay, those two tied together. The P is a mathematical expression that means the log. Okay, so that's why you have a little p, big H. So funny. I love it. All right, so easy enough. You guys will use this whole formula for the rest of calculating pH. Okay? Because it is a negative log, as the concentration of H plus increases, what happens to your guys' pH? As the concentration of H plus increases, what happens to pH? Think about it. It's going to decrease, right? The more acid we have, the more of that H plus we have. Therefore, the lower our pH is going to be. Okay? So more acidic it is. Okay? So because it is a negative log, as the concentration of H plus increases, the pH is going to become more acidic or decrease. Okay? So that number will go down the more hydrogen ions you have. Just basically saying the more acid you have, the more acidic it's going to be. Make sense? Cool. I don't know. There's a quiz, guys, on Wednesday, Thursday on acids and bases. The notebook pages are on the board. So you guys are studying 52 through 55. You guys don't get a retake on this one because you just have to study it to know it.
What if you're not going to be here? When?
Then you'll probably need to take it some other time.
Okay, I'm going to track me.
Okay, good talk. Maybe come in on Thursday.
Probably not.
I'll hunt you down, so help me. I know, that's why I told her to come in on Thursday. Yeah, I don't think I'll accept it that long. Yeah, I'll have it done by the time we take the test.
What if we don't take the test?
Oh my goodness, I can't believe I'm addressing these questions. I'm not done writing the novel. Well, hurry up. Slow writer. All right, let's look at this one, guys. Quiet, please. The pH decreases by a factor of 1 for each tenth of a decimal. Remember that a tenth of a decimal is every time we move a decimal over one place. So when we're looking at scientific notation, those little exponents, those negative exponents, were how many times we moved the decimal, right? That was each a tenth of a decimal. So if we look at 1.0 times 10 to the negative 8th, and we move that decimal one spot, so it's 1.0 times 10 to the negative 7th, we've decreased our pH from 8 to 7. Okay? So each one of those exponents, as it decreases by 1, our pH is going to decrease by 1 as well. Or increase, rather. What's up? No, thank you. Okay? Okay? Just like we use pH, the H plus concentration to calculate pH, we're going to use the hydroxide ion concentration to calculate the OH, POH. Okay? So when we talk about like doing problems and stuff, the biggest thing I'm going to stress to you guys is does what's given to you in the problem line up with what the question's asking for? What I mean by that is if you guys look at the hydrogen or the hydroxide ion concentration, does it line up with the POH? Okay? Those two are the same thing, the OH and the OH, so yes, they do line up. Okay? If I were to give you guys the H plus concentration and ask for the POH, those two don't line up. So that means you guys are going to have more than one step that you need to do to solve this problem. Okay? Just like when we looked at our pH calculation, our H plus ion concentration is equal to the pH is equal to the negative log of the H plus ion concentration. Just like that, we have the POH is equal to the negative log of the hydroxide ion concentration. So it works both ways. Depending on what you put in, that's what you get out. So in this case, we put in hydroxide ion concentration, so we're getting hydroxide, the pH of the hydroxide out. Okay? Or the POH, rather. Sorry, that was a weird way of phrasing it. Let's sneak over here and turn the heat down and see if I can mess the board up.
Are you planning on using that number every day?
Oh, yeah. Aww. Okay? So if a question doesn't line up, for instance, it gives us the OH, the hydroxide ion concentration, but asks us to find the pH, what else can we use to that use there to help us figure that out? How do we get from point A to point B? What? Basically, what's our relationship between pH and POH? Merit? You add them up, they equal 14. Okay? So the 14 is equal to the pH plus POH. So if you guys are given the pH and asked to find the POH, then that's how you do that. Just subtract it from 14. Easy peasy. Okay, vice versa, if you're given the POH, asked to find the pH, then you guys would just subtract that from 14 to find the opposite. Okay? Last little formula I'll give you guys. You won't use it a whole lot, but you guys most certainly can. You guys notice the 1.0 times 10 to the negative 14th. Okay? That's going to be equal to your hydrogen ion concentration multiplied by your hydroxide ion concentration. You guys will use these two more often, just because they're a little bit more simpler, but you guys are more than welcome to use this too. For instance, if I give you guys, all right, the H plus concentration is this. What's our hydroxide ion concentration? You guys could use this one to solve that instead of going, all right, my H plus concentration is this. That means my pH is this. I can subtract that from 14 to find my POH, and then go backwards from POH to OH minus. So you're taking and basically cutting those steps down by 3 if you guys want to do that one. You won't have too many problems that give you guys one concentration, ask for the other. Okay? What you guys need to remember with this is anytime you guys are dealing with acids or bases, they're aqueous solutions. What does it mean if it's aqueous again, Katie? It's dissolved in water. So you guys always have water at play in these reactions. Okay? So if you guys have an acid, remember water is what we call amphoteric. So if you guys have an acid, that water is going to act like a base. So you're always going to have some presence of hydroxide ions if you're using an acid. Okay, same if you're using a base. Your base is going to be your hydroxide ions, but you're always going to have some acid because of the water in there. Okay? So that's why you guys have both H plus and OH. So if you guys have an acid, obviously you're going to have a high level of this and a really low level of that, but they would be multiplied together to form 1.0 times 10 to the negative 14th. Okay? All right, last little section here is what happens if you guys need to calculate the molarity when you're given the pH. Okay, so this is kind of like a reverse of the very first equation I gave you guys, where you guys are given the molarity of H plus ions, and you have to calculate the pH. What happens if I give you guys the pH and ask you guys to find the H plus concentration? Okay, basically it'd be like solving for X, but how do you guys solve for X in a logarithm? So I'll give you guys a second to write that down, and then we'll go look up at our original formula. Tilde? What? No. Who?
Actress.
Huh?
She played Snowpiercer. She was the queen of the train. She made a molecule black gel that was made out of bugs.
He has a lot that goes on in his brain when he sleeps.
No, it's actually
It's not a real.
It's almost nothing, but people think it's empty sometimes. Just like an empty toy, there's like a back of the center lab.
All right, and yeah, let's look back up at our original. Okay, this is our original formula, whether we're using pH or POH. Okay, remember those two numbers would correspond. Basically, if you guys are given this value and asked to find this, how do we solve for that? How do we solve for X? Okay, it's a logarithm. It's not like, oh, divide through by X. Easy peasy, right? So basically what I've done is I've rearranged this formula for you guys. I've kind of given it to you in an extra formula. All that extra formula is rearranging that. Okay, so to rearrange that to solve for your H plus concentration, your formula is going to look, oh crap, like that. H plus concentration is equal to 10 to the negative pH value. Yeah, write this other stuff down. So the formula for pH, as you guys remember, is pH is equal to negative log of H plus concentration. When given the pH, you guys will be solving for the H plus, so we arrange it so it looks like this. Okay, you guys can write this stuff down if you want to. It's pretty much the same thing that we've been talking about. Okay, but the main thing that you guys are getting out of this is this is how we rearrange, okay, to solve for the other given. So your H plus concentration in molarity is equal to 10 to the negative pH value. Again, don't forget that negative. In all of these, there's a negative value you guys need to remember, with the exception of the pH plus POH is equal to 14. Okay, don't forget those negatives. Don't use the subtract sign, use the negative sign. That's, yeah, it means molar. Okay, guys, when you're solving any of these types of problems, what's your label for something in the bracket? Molar, M or molar. Okay, molarity, it's your concentration. Okay, so if you guys are asked to find the H plus or the OH concentration, molar is your formula. What's your unit label for pH? Trick question, there isn't one. Okay, it's just a number. Boom, mind blown. pH is equal to 1.23, whatever. Okay. How do you guys plug this in on your calculator? I set you guys up for failure on that one. Everyone take a look at your calculators and find the log button. Okay. If you guys notice right above the log button, not on a button, but written above the button, it says 10 to the E or whatever. What does it say? 10x. Okay. That's the button you guys are using. So you guys will hit second log. Okay. You guys aren't using your traditional scientific notation, 10 to the caret. You guys aren't typing in 10. You're going second log and then typing in the negative pH value and hitting enter. Okay. So write that last little thing down on a calculator, hit second log.
So we only use log and second?
Yep, so you guys, for these, you're only using the log and second log. Cool. Easy enough? Easy to remember?
No. I guess so.
All right, guys, let's take a look at page 58. We'll do some examples. We have 5 examples to do. Examples? Examples? All right, guys, first example says if we have a hydrogen ion concentration of 2.45 times 10 to the negative fourth. What is our pH? First of all, does this question line up? Does the given and what the question's asking for line up? Yeah, right? We've got H here and H here. So they line up. That means we can get from one to another in one step. Okay? What formula are we going to use for this, Mick? What? Of H plus is equal to our pH. Good. Okay, so we're basically just going to plug this number in and hit enter. So the pH is equal to the negative log. Do not forget that negative or you guys will get a wrong answer. Chances are it'll be negative. So 2.45 times 10 to the negative fourth. Okay, solve for that. Devaney, what do you come up with when you get an answer? So solve just for this. So type in negative log of 2.45 times 10 to the negative fourth. Just don't forget this negative. Okay, good. We'll do 2 decimal points, so 3.61 like Devaney said. Okay, how do we know that answer is correct? How can we check our math?
The answer gives reasonably close to 2.45. It's the same sort of zone.
Not quite. You're on the right track though, Ty. Nope. Well, we do know it's an acid.
Yes, you know, like earlier the one time that I times 2 what negative 4, you put that in, maybe, you say they're always close.
Close to what? So what should it be close to?
Close to negative 4.
It should be regular 4, not negative 4. It should be close to our exponent. Remember, if this was 1.0 instead of 2.45, then your pH would be exactly 4. Okay? We know it's going to be close to that. It's actually going to be a little bit under just about every time. So you guys will know that you're on the right track, at least to a right answer, if you're close to 4, a little bit under that. Okay? So you'll shoot under just a little bit. Okay, next question. We have a hydroxide ion concentration of 6.95 times 10 to the negative 8th. What is our POH? So, Ivan, can we solve directly from OH to POH? Does this question line up? Yes, right? Because we've got OH here, and it's asking for POH. Okay? So what formula are we going to use, Vicente? Good. Okay? So all we have to do is plug in a number. So our POH is going to be equal to the negative log of our hydroxide ion concentration, which is 6.95 times 10 to the negative 8th. Libby, what number should this be close to for pH? It should be close to an 8. It'll probably be a little bit underneath it. So go ahead, plug that in. Let's see here. Merritt, what do you come up with? .16 is correct. Okay? So you guys see it's close to 8. Okay, it's a little bit below it. Well, a lot below it, but it's still close enough. Okay? The bigger this number gets, the further away it gets from 8. Does that make sense? Mind blown. Negative logs. Negative logs. 5. Yeah, 3 more.
What if it's like 1.01?
It'll be close to exactly on.
If it's like, if it was to the negative 30, it's 2.999 or 2.000.
Yeah, it's going to be pretty close. Yep. All right, next problem. All right, we have a hydroxide ion concentration of 7.89 times 10 to the negative 3. What is our pH value? Rachel, does this line up? No. Okay, that means there's more than one step that we're going to have to take here to solve this problem. Okay, let's see here. Tristan, what do you think we're going to have to do first? What is that going to give us? Okay, so that's going to give us the POH. That's a good start. So that's going to equal our POH. Okay, so go ahead and solve for that. Let's see here. Got their calculator ready. Maddie, we go ahead and solve for that and tell me what the POH is. 2.1. So our POH value is 2.10. Okay. Is that what the question's asking for, though? No. So how, let's see here, how, Libby, do we get from POH to pH then? No. Vicente? Subtract 14. Remember that 14 is equal to the pH plus the POH? Okay, we know the POH value, so subtract 14 minus 2.10. You guys come up with a pH value of 11.9. Okay, so that's your guys' value. So again, you'll have at least 2 steps if you guys, what's that? Huh? What do you mean? Yeah, but that's for not when they're lined up, though. Right? So we know that if this is a 3, that means that your POH is going to be something like 11-ish, which does line up. Does that make sense? Okay, 14 minus 3 is 11. I thought you were going to say, unfortunately, all of this makes sense. I'm like, I don't see why that's a big deal. I'm like, that's a great thing. All right, next question. We have 2 more left. This one's backwards. So we were given the pH value and asked to find the H plus concentration. Do these line up? Maddie, do these 2 line up? Yes, right? We've got pH and H plus over here. Okay? So we know that our regular formula is that the pH, nice. Your pH is equal to the negative log of our H plus ion concentration. Okay, so 1.37 is equal to the negative log of our H plus concentration. How do we solve for H plus? We're going to do that's a rhetorical question. Our H plus concentration is equal to 10 to the negative pH value, which is 1.37. Okay, make sure you guys use the second log for that. And Mick, what do you come up for an answer? No. Oh my gosh, I had a typo. Leave me alone. You guys gonna stop asking. Go away. Solve for that. It does work. Make sure you have the negative 1.37. So you take second log and then type in negative 1.37. Right, it's a concentration, right? It's not a pH. We've already had the... Right, so what number do you come up with, Tyler? Give me a couple more, 2 more. 3? No. 0.0427. Okay. Remember that this is concentration. This isn't the same thing as molarity, pH. So your unit label for this will be molarity. How have you guys noticed all of your molarity have been written so far? Like when I give it to you guys on a problem, how is it written? What? Times 10. Scientific notation. That's how I want you guys to write this, especially if it is more than 1 0. Okay, so scientific notation, 4.27 times 10 to the negative 2. Okay, that's how you guys have been used to seeing those. That's why that number kind of threw you off for a second. Okay, your unit label is molar. Yeah, I do want you guys to write it in scientific notation. If it's only like 1 0 in front, I'm okay if you guys write it. But if it's more than 1 0 up front there, do a couple. What? Where you move your decimal over. Remember when it's a small number, it's a negative exponent. This is a small number, so it's a negative exponent. Okay? All right, last question. What molarity of a base is present when you have a pH of 12.12? Okay? When we talk, this is phrased a little bit differently for you guys. What molarity of a base? What concentration are we looking for? The Not the POH.
H plus.
What concentration? The brackets, right? Hydroxide. Okay? Because it's asking molarity of a base. Remember that these brackets mean molarity, and we're looking at a base. A base contributes to hydroxide in OH. Okay? So what molarity of a base is present when you have a pH of 12.12? Do these line up, Grace? No, right? Because we're looking at hydroxide, and it's asking us to find an H. Okay? So we're going to do what first, do you think, Libby? What can we do first? What? We could do that. That's going to take us a little bit longer route. What? Yeah, what's the 14 thing? So 14, what's that going to give us? What value? pH, POH, H plus, OH? POH, right? Remember that our pH plus POH is equal to 14, so we can subtract those. So what do we come up with then for our POH value? We subtract those, we get 1.88. Now where can we go, Grace, from POH of 1.88? Can we go from POH to OH minus? Right. What do we use for that? Tyler? We don't have this written in our notebook. Okay? But what you guys can see that in your notes, you guys have your very first equation that's given to you guys is pH is negative log of H plus. Okay? Your next equation that's given to you guys is for hydroxide. Okay? POH is equal to the negative log of the hydroxide. So this one's backwards though.
So you have to go 10 to negative 1.8.
Right. So it's just the same as saying hydroxide ion is equal to 10 to the negative POH value. Okay? In this case, our POH value is negative 1.88. Okay? So you guys solve for that, and what do you guys come up with for your POH? 0.013. Oops. So you guys get 0.013. That's your hydroxide ion concentration. What's our unit label going to be? What is it, Ivan? Molarity. Good, right? It's a concentration, so it's molarity. Okay. Since it only has 1 0, I'm okay if you guys leave it like that. Just include 2 actual numbers, please. So 0.013. If it's more than like 0.0013, then do scientific notation, okay? All right, any questions? All right, I want you guys to get out that worksheet from Friday. Before you guys get anywhere, I want you guys to finish up those 3 problems. So it would have been like 15 and 16 asked you guys what the formulas for POH and pH are. And then number 19 were questions that you guys actually have to plug into that negative log of the H plus concentration. Okay, then I'll go ahead and pass out you guys' worksheet. It's easy. The first 4 you don't even need a calculator on. Okay? There's only 10, 12 questions.